Hello and welcome back to Black Harbor's official unofficial advanced Tara series. Today we're going to be going through an exercise for item definition focused on window control. That being said, I'm going to let Justin Woods, one of our managers here at Black Harbor Cybersecurity, take over and lead you through the journey.
Awesome. Thank you, Murtada. Happy to be back here again talking to you guys. Let's get right into it. So today we're going to be covering exercise 1.2. Previous exercise 1.1 was covered in the original slides on the fundamentals. So today we will be going over some item definition, specifically item or identifying assets. So starting right off, as he'd mentioned, we're looking at the kind of button controls, right, for the windows. So we have button panel driver, cabin controller, door ECUs, got actuators, and then also a CVM. So we've got some further info in here as well. What we're going to be doing is kind of taking a look at all the different components here, seeing how they connect to each other. And then in a later exercise, we're going to be able to use this information to more accurately kind of dissect what we're seeing and be able to do a more accurate TAR on it, right? Because we've already looked at everything that's in here and be able to really determine what kind of threats or risks might occur in this type of feature and this boundary, right? So going right into the exercise itself, we can start off by just getting a quick look at everything we have in here. We have kind of a where it sits in kind of the IT type world, right? Uh, does it have a physical connection? Is it a networked component? Does it have protocol being sent across it? Does it have a application that's running some form of executable or otherwise? Then what kind of asset is it itself? Or what kind of assets does it have? Is it running those executables? Does it have configuration data? Does it have databases? Does it have some form of unstructured data? Does it have credentials that are stored on it? Does it have logs? And then we also have some in motion type assets here. So PII, perhaps it's sending a GPS signal, then packets. So we can kind of include CAN into the packets here. So are there CAN signals being transmitted? And then in use is going to be memory. So this would be the actual CPUs within the ECUs themselves. And then we also have the relevant properties over here. So perhaps it has a confidentiality issue that we might be able to have an attack on. Perhaps there is a integrity property. A lot of these are going to be for the CAN messages themselves, right? Perhaps it can be kind of spoofed or messed with. And then is availability going to be an issue for the specific asset? Then non-repudiation, with the denial of action taken or failure to acknowledge the request, is that going to be an issue? Then authenticity, accountability, and authorization, are any of these going to be something that might be affecting the specific component, right? So these are all questions that we have to look at as we're kind of going through this item definition here to further understand what kind of attacks might be plausible, right? And then further on, when we get to the non-item definition, we can use these to kind of help us guide our analysis and damage scenario coming up and threat scenarios as well, kind of coming up with all of those. So getting right into it, the first one here, let's just go pretty much top left to bottom right. So we've got the button panel driver. Might be a little hard to see. Let me zoom in here. So we have this button, right? What kind of asset is this? We can go over here, look at kind of these asset types. So the types of information that might be coming off of this, we can see it has a green connection here, which is a pin cable and analog signal. So we can look at through these different assets, decide kind of what makes the most sense. Since there isn't really much else being sent aside from a pretty much physical signal and connection, right? It's not going to be sending a like packet per se. We can say that this is either just physical, which while yes is a layer, is also a form of connection. So we can put that here. And then you might be able to say that this is packets, but for the sake of this example here and this type of connection, I think physical would make the most sense. And then relevant property. So what kind of attacks might be able to be done to the button itself or its connections outward? Well, we can go over here and look at the list of properties and kind of see what lines up the best to it. So for a physical connection, the types of attacks that could be done to this: confidentiality, probably not. Integrity, maybe. Perhaps somebody could spoof this signal by just sending a live connection, or perhaps a lack of signal is what's required to send a request, right? Whatever that case may be, perhaps they're able to do that. But availability is going to be the kind of main issue here. But let's put integrity in there as well, just to keep track of it and show that we are aware that it could be an issue. And then we also have the button panel passenger, which will be the same thing. Awesome. And then we have the cabin controller we'll go into next here. So this is now an ECU. It's going to have slightly different asset types than a physical button and connection. So we also see that it has both a data bus of CAN and a LIN connection to the ECUs as well. So we can look at the different types of assets over here and determine what assets it may have. So one thing to point out here is that a single asset may have multiple asset types within it. So this ECU, maybe it'll store logs on it. It definitely is sending packets, right, across the different connections that it has. It has memory on it to be running the CPU within it. It is running executables to take those inputs from the buttons and say, okay, this is coming from the driver side, this is coming from the passenger side, and then sending the correct request to the actual door ECUs. And that looks like it's about it for what it might have. Awesome. Now we can get into the relevant properties. So if we look at it again here, we can see the types of assets it has. So what kind of attacks might be kind of able to be used against these assets to affect this feature, right? So confidentiality, again, not really going to be much of an issue, even if they can see the information. Doesn't matter if they can't do anything with it. However, integrity, if they are able to mess with either data coming in or going out, that might be an issue. So integrity is going to be listed here. Availability also would be an issue, as a window not being able to be opened or closed could pose a threat, right? Of course, when you get into the damage scenarios, we'll kind of dive more into how these will possibly be a threat. And then authenticity. Um, perhaps this might be an issue, right? Having the door ECUs know that it is the uh, cabin controller who is making the request is going to be important in terms of securing the system and not having other ECUs be able to send the same message and have it still be taken, right? So authenticity might be an issue. Then accountability. This is only going to be an issue because we just kind of assumed that it has logs as an asset type. Of course, this isn't a known thing, right? We would have to kind of go to the uh, original feature owner and verify with them that this does have logs. But for the sake of the exercise, let's just say it does. So we'll say that it does have a accountability portion to it. Okay, let's go to the door ECUs now. So we have door ECU left, and of course we'll also have door ECU right. So rolling back to the asset types here. So another ECU, but it also now has a physical connection to an actuator. So what type of asset types might this have? Let's roll through these again, take a look. Perhaps we're now no longer doing the logging, as that would be handled by the cabin controller, so it might not have that. We do see that there is a LIN connection to the cabin controller, and perhaps there is a back and forth of packets that are discussing what state the window is at. So packets might be one. And then memory, right? It is an ECU. It likely will have to have some form of memory to perform some of its actions. And then executables, right? Because it's going to be getting those messages from the cabin controller saying, hey, open or close this window. It'll have to take that and be like, okay, I've been sent this request. Let's now change this request into a actual movement of the actuator to whatever degree the request was requesting, right? Awesome. And now we can get into the properties again. So of course, left and right will have the same asset types as well. Let's copy that over now. And again here, the types of properties that are affecting this are going to be pretty similar to the cabin controller, aside from the accountability, right? Because any type of integrity issue would possibly result in kind of the same issue as the cabin controller of opening or closing the window incorrectly. So integrity definitely would be an issue, since it does have that that LIN connection as well as the executables themselves. Both of those could be tampered with, and that would be a integrity issue. And then we have availability. Again, the lack of the ECU itself or its features means that the window would not be able to be opened or closed. So clearly that itself is an attack. And again, later we can go into how that might cause some form of damage. And then we can also look through the rest of these. Perhaps there's another one that'll fit. Confidentiality. No, the data going in can be seen. Doesn't really matter too much. Non-repudiation. Doesn't seem like it really fits. Authenticity. Nah, probably not. Accountability. Doesn't have any logging. Then authorization, entity privilege. Perhaps this might also kind of go back to the buttons themselves, meaning who is able to actually press the buttons. But in this case, it is inside the vehicle. So we can determine that if somebody is pressing the button from that side, they have authorization to press said button. And when it comes to the door ECU, the authorization we can look at as the cabin controller sending the correct request due to the button being pressed. So again, that would all kind of be already within the vehicle. So we'll be done here with integrity and availability. Again, same thing for both. And now we can go to not the actuators, actually, in terms of the item definition rather than kind of the asset type of identifying we're doing here. You would mark down these actuators if you were just mapping out the system and relating them to damage scenarios. However, attacks on actuators themselves aren't exactly like cybersecurity related, as the actuator itself is pretty much a purely physical device, right? It gets sent a signal, performs some action. There's no logic or connections kind of outside of that going on there. So last one here is going to be the CVM. And if we look here, we have the CVM is cabin controller CAN has external access outside car body. So what this is saying is that the CVM is able to open and close the windows remotely, actually. I believe it says that somewhere. We'll roll with it anyways. So let's say that the CVM is able to receive a signal from a key fob. Perhaps it's like locking the door and then holding the unlock button, or unlocking the car and then holding the unlock. Perhaps that'll open the windows or something along those lines, right? So with that, we can kind of have that knowledge going into this, start identifying some of the assets of it. So for the ECU itself, it'll have kind of that same trifecta of ECU asset types of packets, memory, and executables. But now we also have to think, okay, it does have a connection to a key fob as well. Does that change up these asset types at all? So we can look through here. We have executables, clearly we already marked that. Configuration data, this might be something that it has, or perhaps a database to kind of list the connection to the key fob, or perhaps it's unstructured data, right? We would want to verify with the feature owner what type of data or how it's stored. For a key fob, it's likely going to be some form of database that it has on it. So we can write that for now. Then credentials, kind of the same thing, but we can kind of lump that into the database here. And then logs, this might be something it has as well to keep track of the opening and closing of the door or of the window. And then PII, not really going to have any of that. Packets we've already listed as it does have that CAN connection back to the cabin controller. And then memory, already got that listed as well. So we're all good there. Let's get back to the properties now. I keep sliding this little table around. Get back here. Okay. Relevant properties. So what type of attacks might be able to be done here? Of course, kind of the integrity and availability, always going to be a bit of an issue, right? Especially for this system here. So we can just kind of drag those on over. Then we can think about the other connections it now has and the other types of attacks that can be done on them. So again, since we have logs, that means that the accountability might be an issue. In case those logs were to be tampered with, removed, or I guess it's kind of it. If they're working fine, they're working fine, right? So now we can look at the rest of these here. We have confidentiality, not really going to be as much of an issue, that we wouldn't really want to disclose the signal itself that's being sent from the key fob to the CVM, as there are going to be counters and keys and such kind of mixed in there. Probably not going to be too big of an issue. This would be for like the replays and such, which kind of falls into the integrity category anyways. Availability, we've already marked as an issue. Non-repudiation might be a bit of an issue in case somebody were to send a request and it were to not be acknowledged. So let's just throw that in for now. Then authenticity, the entity identity. That's kind of a fun thing to say, not gonna lie. So the authenticity, this would be coming from the key fob. So having some form of authenticity from it to the CVM, and then further from the CVM to the cabin controller as well. That all actually would matter in this scenario as well. Because of course we want to verify that the correct key fob is sending the request to open it, right? Accountability we already have listed. Then authorization. Authorization can kind of be like a user group type of thing in terms of the key fob that falls more under the authenticity than it does authorization. So awesome. That is pretty much this exercise done. We have looked at all of the assets here, listed the different types of asset types and properties for them. And now we can roll back to the slides here. And we are done.
Justin, that was a solid transition in between tabs. Good job. Okay, well that wraps everything up on our end. Hope you all have enjoyed this, and we look forward to releasing the next one. Talk to y'all soon.